Number 59, integrated concepts. Cold vaporizers pass a current through water, evaporating it with only a small increase in temperature. One such home device is rated at 3.5 amps and utilizes 120 volt of alternating current with 95% efficiency. Letter A, what is the vaporization rate in grams per minute? All right, so first let's start with the question it's asking, what is the vaporization rate in grams per minute? All right, so in other words, we need to find a mass divided by time. Right, and these units have to be in terms of grams, and the time has to be in terms of minute, all right, or minutes. So what I'm going to focus on is I'm going to focus on these units. I need to find mass and I need to find time, all right, or the relative. I don't need to actually find both if I could just find a relative calculation between them. I don't necessarily have to find the mass exactly and the time exactly and then plug it in. You'll see in a second. So, all right, so now I start to think about then the nature of the problem. In other words, we're vaporizing something. And to vaporize something, it takes, I don't know, energy. So if it takes energy, I'm thinking to myself, how is then energy related to the given information of current and voltage? Well, it's related through power, right? Power. In other words, we can use this formula that the power supplied is going to equal the current supplied, or the current flowing through a particular object or wire, whatever the case is. Not wire in this case, it's water, but who cares, right? It's the current flowing through an object multiplied then by the voltage applied. Now power, you have to remember, is a unit of energy per time, right? Power is essentially energy per time. That's what it is, right? It's joules per second, or AKA it's watts. So I'm just simply going to plug in E over T. And I'll get my I over here, and then I got my V, okay? And that comes simply from the formula from, way back when, all right? That power is equal to energy over time. So now that I know this particular relationship, I'm starting to say, oh, interesting. Here I have my energy, right? And here I have my time. Now, one thing I want to take into account before we get any further is this kind of 95% efficiency. And what that basically means is that whatever current and voltage is being applied, only 95% of it will be able to be transferred into direct power, utilized to vaporize that water. And in other words, what I'm saying is that I can simply now take that value of 95%. Remember, whenever you do math with percents, you have to use a decimal. And I'm going to plug it in on the right-hand side, just like so. That should hopefully make sense, right? This is what I'm saying here is now 98% of whatever current and voltage being supplied is going to be translated directly to the power. Okay? So, now, where do we go from here? So what I need to now do is I realize I have time here. So I have to now turn my attention, and look, I have time here. Now I have to turn my attention to somehow figure out, how do I get rid of this energy? And this is the key part now. This is where you're jumping chapters. In other words, we have to realize that the energy required to vaporize something is the same as heat energy, right? To vaporize it. So instead of calling this E, it might be more helpful to call it Q. It doesn't matter. It's still energy, but it might help you visualize it or be able to connect some ideas together. So let's call it Q. Q represents the heat energy. It's just a more specific type. Instead of just calling it general energy, we're calling it heat energy now. So heat energy. How is now heat energy, right? Heat energy related now to vaporization. Oh, wait a minute. Is that like the latent heat of vaporization, or the energy it takes to vaporize something? Oh, right. Is that this formula? Is that the formula that the energy required to vaporize something will be equal to the mass that you're looking to vaporize multiplied by that latent heat of vaporization constant for whatever material you're talking about? Yes, that is the case, right? This is the formula. I don't remember what chapter. 13, 14, 15, somewhere around there. And what I now can do is I can now substitute this on in, and I realize that, wait a minute, I have my mass, right? So now I have my mass, and I'm going to do that. You know what I'll do? Let's move this on over a little bit. Let's move this on over. I'll move this over here, get more room on the right-hand side. All right, so now what we're going to do is we're going to substitute that on in. So we got mass multiplied by the latent heat of vaporization of the water divided by time, and that will equal now 0.98 times the current multiplied by the voltage. Look at this now. Boom, 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 boom. I got it. All I now need to do is get rid of the latent heat of vaporization of water, and I can just simply cross multiply that on down, right? Whoop, just like that. We've done that plenty of times now, and there's the formula. There it is. Now the only thing is that we have to be careful because you have to know that the time here, standard unit of time is seconds. All right, so why don't we just solve it and then we'll do our conversion. So notice that this now represents the grams per second. That's the mass. Oh, excuse me. I was doing chemistry a little earlier. So the physics, kilograms. Right, standard unit of gram here is going to be for kilogram, and this is per second. All right, so let's just calculate it. So this is now 0.98 multiplied by the current of 3.5, multiplied then by the voltage, which is 120, divided all then by the latent heat of vaporization. You got to look that up. 2256 or 2,256, and that's in kilojoules per kilogram. Okay, and yeah, another thing I realize here is that we're going to now need to convert this, to joules. All right, we cannot plug it in kilojoules. Remember, all I'm doing is I'm making sure I have all my standard units of physics that go into this formula. That's how I know I need to convert this. You know that we normally do calculations with joules and not kilojoules. So I just have to simply now take this and then write kilojoule on the bottom, joule on the top, 1,000 joules for 1 kilojoule, and we can now convert this. So this will be 22 million now, approximately. So simply add, let's go over here, simply add your 3 zeros. Okay, and now we're going to calculate. So let's see. There's a lot going on in the problem. 3.5 times 120 divided then by 2256000. So 1.82. 1.82 times 10 to the minus fourth. And those are the units there of kilojoule per second. Or, kilogram per second. Now all I need to do is convert that into gram per minute, right? So I'll do that on the top left. So we have now 1.82 times 10 to the minus fourth kilogram per second. Get rid of the kilograms on the bottom, grams on the top, 1,000 grams and 1 kilogram. Great, we'll see you later. Now we got to convert from seconds to minutes. So seconds on the top so that they cancel because this starts on the bottom, minutes on the bottom. And then we got 60 seconds in a minute and we are good to go. So see you later seconds, see you later kilograms, and that's all we got to do. So we'll take that value, multiply it then by 1,000, and then multiply it by 60. So about 10.9, right? So we got here about 10, 10.9, 10.9. What is that? Grams per minute? Okay, there you go. All right. So, sure, that takes care of that. And now it's asking how much water then, right? How much, where's my eraser? Let's erase a lot of this stuff. So now how much water? Okay. Hope you're having a nice semester so far, right? Okay. All right. And how much water must you put into the vaporizer for 8 hours of overnight operation? So this is just now a simple conversion involving this value. So we got 10.9 grams. It's going to vaporize 10.9 grams per minute. But we have hours of operation, right? So let's get rid of the minute, convert this to hours so we know the rate of how many grams would be utilized then per hour, right? Because the minutes would cancel. And then all you got to simply do is plug in your 8 hours and we're good to go. So 10.9 times 60 times 8. So it looks like it's going to be about 5,254 grams. Okay. All right. So that sounds kind of high to me. Hopefully I didn't make a mistake. Anyway, thanks guys for tuning in. Appreciate it very much. Please remember to help us out and subscribe, and we'll see you soon. Take care.